Hey everybody. In class today we got a little practice using point slope form. Tonight we're just going to go through a few more examples and get a little bit more practice, get a little bit more comfortable with it. So remember, point slope form looks like this. Y minus y1 equals m times x minus x1. And remember, y1 and x1, these variables here, represent the coordinates of one point on the line that has slope m. In our first example here, we have to find the slope. So we can use our slope formula. Lots of formulas that we're learning. That's a good reason to use the foldable that we have to keep everything straight. So to find our slope, let's do y2, the second y value, minus y1, the first y value. And then we'll do the same with the x values. Make sure we go in the same order that we did the first time. So we can simplify these. -7 minus -1 is -6. And 6 minus -4 is 10. And I want to make sure I simplify this. That's going to give me -3 over 5. So there's our slope. Now we just need to pick one of these 2 points to put into our slope-intercept form. I am going to choose the point on the right here, our second point, just because it has one positive value. It has +6. The other one doesn't have any positive value. So this is the one I'm going to use. Now, even though for our slope we use this as x2 and y2, it doesn't matter when we're putting it into point slope form. x1 and y1 just represent the coordinates of any one point. So it could be this one or this one. So let's go ahead and put that in. We have y minus -7 equals -3 over 5 times x minus 6. So we're using subtraction for both of those. We could simplify this one on the left. Y minus -7 is the same as y plus 7 equals -3 over 5 times x minus 6. So this is our equation in point slope form. Now, if we wanted to, we could convert this into slope-intercept form. We could do the distributive property with the -3 over 5, and then we could subtract 7 from both sides to isolate y. But my main focus right now is just getting these equations down in point slope form. We can work on converting it later. In our second example, we have a graph this time, and we have 2 points plotted. We have 1, 2, and 4, 4. We're going to do the same thing, write an equation in point slope form. So the first thing I need to know for my line is the slope. So to do that, I could use the formula y2 minus y1 over x2 minus x1, but I'm just going to find my change in y and my change in x from the graph here. So I can go up 2, so my rise is 2, and I can go to the right 3. My run is 3. So delta y is 2, delta x is 3. And there is my slope. Now, I have to pick one of these points. It doesn't matter which one. Let's go with 4, 4. They're the same number. That should make things easy. So y minus y1, my y value for that point is 4, equals the slope, 2 over 3, times x minus the x value from that point, which is 4. And here is my equation in point slope form. So we've practiced writing a couple of equations in point slope form. What if we have an equation in point slope form and we want to put it on a graph? How do we do that? It's actually not too different from doing it in slope-intercept form. Right? In slope-intercept form, we always want to find the y-intercept. We start with that, and then we use the slope to find other points. In this case, we're still going to use the slope. We know our slope is 2/3, and we need a starting point. And our starting point needs an x and a y value, right? Now, I know my x value here from this equation. I have a point, and my x value is 3. And my y value is going to be -2. Because this says y plus 2. Remember, point slope form says y minus y1. So if this says plus, it means that this must be a -2. So here are my coordinates of a point, and here's my slope. So I'm just going to plot that point and then use the slope to find more points. So 3, -2 is going to be right here on my coordinate plane, and my slope is +2/3, so I'm going to go up 2 and to the right 3. I can also reverse those directions, down 2 and to the left 3, down 2 and to the left 3. And I have 4 points now for my graph. And we'll just draw a semi-straight line. Maybe you can do yours better than I can. And there we go. We have a line that matches this graph. Now, we can actually see here and see if we graphed it right by turning this equation into slope-intercept form. Let's distribute the slope here. That's going to give me y plus 2 equals 2/3 x, and then 2/3 times -3 is going to give me -2. And now I subtract 2 from both sides to get y by itself, and I get y equals 2/3 x minus 4. And notice where my y-intercept is on this graph. It's at -4, which is exactly what this equation says. So we can graph this equation by finding the point and then finding the slope and putting those on there. We could also do it in slope-intercept form if we wanted. Let's look at one more here. Example D, I know my slope here. Now my slope is whatever's in front of these parentheses, and we just have a negative sign. So my slope is going to be -1. And my point, now I have x plus 4. So that's the same as x minus -4. So I know my x value is -4, and my y value must be -1. So I can plot those points, -4, -1, or plot that one point, and then use my slope to find other points. -1 over 1, down 1 to the right one, down 1 to the right one, down 1 to the right one, and we can just keep going. And I'll try to draw the best line I can in this app. There we go. Not horrible. Not great, but not horrible. Now, let's check it once again by putting this in slope-intercept form. Let's distribute that -1. Y plus 1 equals -1x, and then -1 times 4 is -4. And then I subtract 1 from both sides, and I get y equals -x minus 5. And notice this equation, which is the same as this equation, right? We just changed the format, changed the way it looks, has a y-intercept of -5 and a slope of -1. So this new form still matches our graph. So that's a good indicator that we've done the right thing. Okay, that's all of our notes for tonight. You guys can go ahead and wrap these up, and I will see you in class.